Hello everyone. Today we will discuss about database design using a ER model. What is database design? It's a set of procedures or collection of tasks for organizing the data to implement a database. It has got several key steps to ensure efficient storage, retrieval and manipulation of data. The first step would be requirement analysis. Now, when we talk about designing a database, we need to concentrate on what data to be stored in the database, what applications to be built on top of it to retrieve the data, and what operation to perform to meet the performance requirements. So, the first step is requirement analysis. Using the information gathered here in requirement analysis, a conceptual database is designed which is used to develop a high level description of the data to be stored in the database along with its constraints. The next step would be a logical database design, which is choosing a particular corresponding data model to implement the database design and convert the conceptual design into a database schema. That is the structure using a data model which has been selected. Beyond these data models, that is something higher level, would be schema refinement, physical database design and application and security design. What is schema refinement? We were discussing about the quality of DBMS where data is not redundant, or otherwise we have less redundancy. How do we ensure that? This is through this particular schema refinement. The schema or the structure talks about different tables, and those tables can be refined or otherwise split into multiple tables to ensure that there is no redundancy of data and data access is much easier or of better quality, efficient. Physical database design decides on the storage structures, indexing strategies and partitioning. So, optimize performance considerations for us, query execution time and storage space usage is all dealt in this physical database design part. Coming to the application and the security design, this talks about those application development, that is those interfaces or application programs built in order to access them, implement the security measures such as authorization or protecting of the data through encryption or enforcing the integrity constraints, etc. So, these are the various steps that are involved, and in that the first three steps becomes the part of our data models. Now, we will take ER model as an example to work with database design. Now, how is this ER model, or what is this? Entity relationship model. It specifies an enterprise schema that represents the logical structure of the database graphically. That is, it is going to show the relationship between the entities in a graphical or a diagrammatic representation. Basically, these entities are nothing but real world objects. So, the real world scenarios are more precisely explained through the ER diagrams or ER model. So, it was proposed by Peter Chen in 1971 as a uniform convention for representing our relational models. Now, let us see what are the components of these ER models, or basically ER diagram. So, three major components: entity, attribute and relation. We can just discuss about each one of them one by one. Entity is basically an object, attributes is the characteristics of those objects, and relation is going to be the association between these entities. Let us get back to it. The symbols used are going to be entity is represented using represented using this particular rectangle. Attributes will be represented using the oval, and in entity types we have differences when we get into particularly that we will see, and relationship would be a rhombus. So, we have this rectangles to represent the entity, ellipses for the attributes, diamonds or the rhombus for the relationship, lines to connect them, then primary key, double ellipse, double rectangle, all these things represent different types. So, let us get into entities. Now, when I talk about an entity, as we said, it is a real life object. So, it can be a physical object or a conceptual object. See, any object which is of physical existence, that is person, thing, animal. I talk about student, customer, employee, or we talk about things like say commodities or raw materials, anything like this, that becomes your physical existence. Coming to conceptual existence, I can talk about event or course. Okay, these are going to be the entities of conceptual existence. Now, entity is showcased using a rectangle. Here if we see, student and course are the two entities. Okay. So, coming back next. Okay, relationship is they study, student studies a course. Okay, there is rectangles are your entities. Now, a collection of group of entities sharing the same set of attributes are called as entity set. Now, when I say student instance, multiple instances of students make an entity set. So, this is going to be an entity set here. Okay. Now, entities can be distinctly identified using in an entity set, and these are all entries have a different set of values for some set of attributes. That is like each instance within this is an entity, whereas the complete all the set of, and each instant can be uniquely identified, again that is what is being told there, and this whole set is called as your entity set. Yeah. There are two types of entities, strong entity and weak entity. The general example of entity what we speak is strong entity. That means it has got a key attribute where each individual instance of it can be uniquely identified. An entity that has its own existence and is independent. Example is student. Every student, say for example, we are talking about students of KMIT, we are talking about every individual is separately or uniquely identified, and it is self-dependent or its own existence and independent. Whereas, when we talk about a weak entity, it is dependent on one of the strong entity. So, let us get into that. Before that, an entity relationship diagram represents a strong entity type with the help of a single rectangle, just a single rectangle. Here is an example, a student is a strong entity, professor is a strong entity. Each student is identified using the student identity number. Each one, it is not duplicating, it is not null or it is not repeating. So, uniquely can identify. Similarly, every professor has got the social security number. Coming to the weak entity, as I said, it is dependent on another entity. So, one example here is customer borrows loan. So, loan is an entity, but loan by itself cannot be or does not exist. It is dependent on this entity customer, because customer takes the loan. The loan is identified by the customer. Here customer has got its own key attribute, whereas loan is associated with that particular customer ID. Similarly, we can say employee, okay, of an organization has, say, dependent. This is another example. Now, what is this? Maybe the management has decided to give medical facility to all its employees. Then their dependents, that means family members detail, also has to be collected and stored. For storing that, I have created an entity called as dependents. Now, this dependent entity is dependent on the employee entity. So, if you see, the employee entity has a single rectangle and the dependent entity, which is weak entity, has been represented using a double rectangle. Okay. So these are some of the examples for weak entity: customer having the address, or otherwise officer making the loan payment, something like this. Okay. Now coming to the attributes. Attributes are nothing but the characteristics. The characteristics of an entity is called as attributes. Example is ID, phone number, name, age, etc. Now attributes are represented using the oval. What are the types of attributes? We have key attributes, simple versus composite attribute, single valued versus multi-valued attribute, stored versus derived attribute, required versus optional attribute. A key attribute which is identified with a, say, student number with an underline is the key attribute which uniquely identifies the records, that is instances of the entity. Composite attributes, it is simple versus composite. Now for example, if I say student roll number, it is a single component, or I say date of birth, simple one. But if I say name, it may have subparts in it, that is first name, middle name and last name. So component. Or I take address, address may have subcomponents like street number or house number, then you may have the street or you may have the city. This is going to be a composite attribute. Multi-valued attribute, that single versus multi-valued. When I talk about name, name is, he will have single name, or otherwise date of birth, single value. But phone number, email ID, if I take more than one value, that is what is multi-valued attribute. If you see, a multi-valued attribute is represented using double oval. Derived attribute, stored versus derived. I said certain attributes are stored in the database, whereas few attributes are derived from the stored value. That is, for example, when I talk in terms of age, date of birth is a stored attribute, whereas age is derived from date of birth. When I calculate the age today, it is some value. When I calculate it after 2 years, it is some other value. So that is derived, which is represented using your dotted rectangle, dotted oval. Coming to the next concept called as relationship. The relationship is the association between the two entities, which is represented using a diamond shape. And if we see, student is related to course because he studies that course. So the relationship is studying. So the diamond shape showcases the relationship and it depicts the association between the two entities. Coming to the relationship types, we have one-to-one, one-to-many, many-to-one and many-to-many. What do you mean by one-to-one relationship? When single element of an entity is associated with single element of another entity, it is called as one-to-one relationship. This is very rarely used, but let me just tell you an example. A student may have an identification card. In the college, a student will have one ID card. So, one-to-one, one entity is associated with one. One-to-many, here a single entity of an entity set is associated with more than one entities, one or more entities of another entity set. For example, a customer may place multiple orders, or a student may enroll into more than one courses. A artist may have several paintings. These are all examples of one-to-many. Coming to many-to-one relationship, here a multiple instances of one entity is associated with one instant of another entity. That is, many students take up a course. Many painters participates in an exhibition. So when we are painting exhibition, so we are talking about many-to-one relationship. Finally, coming to many-to-many relationship, when more than one element of one entity set is associated with one or more elements of another entity set, we call it as many-to-many. Employees can be assigned with multiple projects, and one project may have multiple employees. Okay. Similarly, a student taking more than one course. and one course having multiple student is going to be the example of many to many relationship.